Welcome to the lesson on constructions with perimeter. In this lesson, we will do a few basic constructions and revolve them around perimeter and the ideas of perimeter. Now we know that constructions can be made to meet the constraints of perimeter. That is, that we could possibly construct a figure that must have a certain perimeter. And by using a simple perpendicular bisector, we can construct squares and triangles to meet those certain requirements. Now let's start off by constructing a square that meets a certain perimeter. Now the first thing that we can think about is to go ahead and make a line. Now this line doesn't have to be any given length, but I know that I want to make a square that has the perimeter of this line. The square and this line have the same exact length. So I'll start off by making a perpendicular bisector. I can take my compass, open it up to more than half of my segment, and make an arc above and below the segment. And without changing my compass's measurement, I'll do the same thing from the other endpoint of my segment. So now I can put 2 points at the 2 intersections of those arcs and connect those 2 points to make a perpendicular bisector. And in this case, I made this second line much longer past the top point. So now, since I have halfway of this segment, I want to find halfway of the halfway segment. So I'll do the same thing. I'll make the same perpendicular bisector, but from just half of the segment. So open up to more than half, put an arc on the top and the bottom. Without changing the measurements, I'll do it from the other endpoint of the halfway segment. And I'll do the same thing, make 2 points of those arc intersections and connect those 2 points to make another long line. So essentially, I've made another perpendicular bisector, but in this case, I've made it halfway. So between the 2 lines that I've made on my original line, I'll highlight that line in blue because that's going to be one of the lines of my square. And since a square has to have all equal sides, I'm going to open my compass to this blue line that I made and make an arc up here on one of the bisectors I made, and make another arc on the other bisector that I made, because that'll measure out the same distance for the second and third sides of my square. And I'll also outline these in blue so that you can see how my square is coming together. Lastly, I can use my straight edge to connect the second and third line to make the fourth line. Now I've made a square that is the length of my original line segment. So now I'm going to use some of the same principles to construct an isosceles triangle instead. So I start off much the same way, with a line of a set distance that will reflect the perimeter of my isosceles triangle. Remember, an isosceles triangle is going to have 2 equal sides. So I will go ahead and make another line that will serve as the base of my isosceles triangle, or at least I'll be able to make the base here, and I'll label the original line as part of the base that I want. Now, it's important that your base is not more than half of your original line, but I'll use my compass to mark out this exact same base, and I'll use my marker to highlight what will be the base of my isosceles triangle. So now, since the 2 remaining sides must be equal, I should go ahead and find the perpendicular bisector of the remaining line of my original line segment. I'll do the same thing. Open my compass to more than half, make arcs on top and bottom of the segment from both endpoints, connect those arcs, and I get a perpendicular bisector. And now I can go to my original midpoint or other endpoints, measure out the distance, and that will give me exactly what the sides of my isosceles triangle need to be. So I'll go to one endpoint of my triangle, make an arc. I'll go to the other endpoint of my triangle and make an arc. And where those 2 arcs connect will be where those 2 sides, the 2 isosceles sides, will end up meeting. So I'll go ahead and make those sides in blue. And by using these tools, I've been able to make an isosceles triangle, 2 equal sides, that has the same perimeter, or has a perimeter denoted by the length of my original segment.